Hello and welcome to our user group today. Oh. So we are a Pittsburgh.NET user group. We are based out of Pittsburgh, Pennsylvania, and our social links are available here. Join. Today we're going to look into increased observability and resilience with dev usability with .NET Aspire. We have our seasoned speaker, Lee. Welcome, Lee. Thanks for joining us today and sharing your insights here.
Yeah, thanks for having me, Bill.
Thank you. All yours.
All right. Welcome everybody. So yeah, this presentation is increased observability, resiliency, and dev usability with .NET Aspire. So I'm gonna go over a little bit of background. First, real quick about myself. I'm Microsoft MVP. I run the Cap Area .NET user group. And if you're interested, next week we're actually doing a talk on SQL Server temporal tables, which would be interesting. That's Tuesday. Check that out on Meetup if that sounds interesting. I work for a great company, Inferno Red. If you're looking for work, maybe give me a ring. Blogger, YouTuber, I'm a speaker, maker, runner, mountain biker, woodworker, 3D printer, author of Sire Shame, if you are familiar with that. I'm on my Twitter and LinkedIn. But one thing is, I've been in this industry for a long time now. I graduated in 1999, which is when I entered the workforce. And I've been doing consulting and software development that's 25 years. I was counting it up and I was kind of amazed at how long it's been. So I've seen a lot of things in 25 years. I don't know if any of my
Lee,
anyone here remembers. Oh yeah, go ahead, Paul.
Can you hit that hide button in the bottom of the bar? It's easier when you're sharing.
Oh yeah, you bet.
Thank you very much. Go ahead. Sorry about that.
Yeah, sure. So yeah, I don't know if anyone in the audience remembers this. This was how the web looked in 1999. Let's see, lost my cursor, but it also looked a bit like this. This was Google Beta. I don't know if anyone remember Ask Jeeves. There was what the Apple looked like back then. AOL was still a thing. And architecture-wise, this was what architectures looked like back in 1999. We had IE6, or maybe it was IE5 at the time, connecting up to IIS7 with active server pages. And then we had COM components. And those COM components were written in VB6 with the data access tier. They called stored procedures. So yeah, we'd write the UIs in Visual InterDev, and we used VB6 and SQL Server 7. And these architectures needed to scale similar to apps today. There's a lot of similarities. And so we would scale up those COM components, and that was how we would handle scaling. But times have changed. And interestingly enough, that slide that I did right back there, I just a quick aside, I did that in ChatGPT. I sort of described what I wanted, and then I was like, hey, can you generate me the mermaid for this? And then I plugged it over into a mermaid generator. And I just trying to think, like 25 years ago, you would have blown my mind if you had told me I was going to be using AI in 25 years like this. So 6 years ago, in 2018, I've worked on a lot of different architectures, but I don't know if anyone can remember what architectures were popular in 2018. I don't know. Are there folks online? Here, I'll give you a hint. What
they are, and there have been comments here coming through.
Oh, I'm not seeing the comments. Yeah, nice.
Put it on the screen here.
I see that. Oh, there we go. Yep. Okay, layers. Yeah, there we go. Perfect. Yeah, Kubernetes. So Kubernetes was really popular 6 years ago. Still popular today. Microservices are still popular today, and a lot of people were just throwing Kubernetes into whatever apps they needed. But this customer that I was working on had an actual need for Kubernetes. It actually ended up being a pretty good solution for them. They were a fintech startup company. So financial services company. And what they needed to be able to do was, throughout the course of the day, people hardly ever hit their site. But then the market's closed, and at 5 p.m. or 4:30, whenever the market's closed, then all of the customers would descend upon this client, and they needed to scale from basically zero, and they needed to scale up to medium level to be able to do some financially stuff. Then they would get the information they needed, they'd scale back down to zero, and then come around midnight, 1 a.m., 2 a.m., they would get this load of data of all the transactions that occurred on the stock market throughout the course of the day, which is a massive amount of data. And so then they would need to be able to process this massive amount of data and then transform it and turn it into a covariance matrix, which then would feed the next day's worth of things that they needed to do. So the architecture looked like, there we go. It looked like this. So I don't know if you all have familiar with Kubernetes, but this box here, this inner box here, is the Kubernetes instance. And inside of it are these pods. And each one of these pods, the idea is that the container orchestrator, Kubernetes in this case, is going to monitor all of those pods. And if any of them ever crashes for any reason, it'll restart them. But more importantly, it also has the ability to scale them. So this covariance calculator pod down here was written in R. And so we had the ability to scale that up. And especially as they wanted to add additional markets, the need to be able to scale these things was high. And so this architecture ended up working pretty well for them. There's a traffic manager up here. They had a primary cluster for Kubernetes, and they had this failover cluster. I didn't go into any details in this architecture, but there's an ingress prod, there's an FTP server, there's and then there's some servers and databases or whatever. Sounds great in theory, but I don't know. Has anyone here used Kubernetes? Sean, have you used Kubernetes? I can tell you right off the bat, one problem with it, it is really complicated. And it was, I feel bad for anyone onboarding onto this project because there's just so much complexity. There's so many environment variables everywhere. PowerShell scripts, there's so many of them everywhere. And VNets, like I had to learn so much more about networking than I have ever wanted to know about address spaces and how to segment which things go where in the address space, and ports, so many ports, so much health checks. You have to write a health check for each one of these pods to reliably determine if it's happy or broken or somewhere in the middle. It's like, how is each one of these things feeling today? And you got to deal with resiliency. And so the whole thing was very, very complicated. So this project is like perfect for .NET Aspire. And it turns out that there's a lot of projects out there like that. If you go to the landscape.cncf.io, this is going to give you some kind of sense of how many different ways there are to compose microservices out there. This is like and this screenshot just touches the surface. There's so much stuff out there, so many different ways you can compose your microservices if that's your architecture. That I think theoretically this site is trying to be helpful, but I think it also works out really well in a slide just to show how complicated the landscape is for building cloud native apps. So fast forward to today, and I'm working on a completely different project. And it is almost so different that it's funny. Anyone want to take a guess what could be opposite? I guess there could be a lot of things that could be opposite. I'll give you a hint. It uses Blazor Server. I love Blazor Server. I'm a huge fan. And one of the things that's just really nice about it is you deploy it into an app service in Azure, and everything is all in one place. It's like a monolith. It is the exact opposite of microservices architecture, to the point that there's, like in a traditional spa, I didn't even mention it, but in the previous project, we were using Angular. Blazor Server is nice. Blazor WASM is nicer. And Blazor Hybrid is better than both of those. Yeah, I'm with you. I'm with you, Sean. So the nice thing about Blazor Server that works really well for this is it's an internal product for a business client. So there's not going to be that many users. There's probably never going to be more than a couple dozen people hitting the site at any given point in time, and they've got a pretty reliable connection to the server. So Blazor Server makes life really very easy. So the complexity is really low for this app. I don't have to worry about health checks. Don't have to really worry about resiliency so much. I mean, I guess they do need to worry about what happens if their connection to the internet goes out. Maybe it would be nice if their apps if they could still be productive without a connection to the internet, but resiliency is much less of an issue. However, observability is a concern which this app shares, as does the Kubernetes app, as does the apps back written in 1999. If you have a bug in your app that's in production, you need a way to be able to dig into it and understand what went wrong and how it went wrong and how you can fix it. So observability is that one key thing that really matters to all apps, even simple ones like this. So I'm going to compare these two applications a little bit, because I would imagine in the audience today, there are folks that have more complicated architectures like the Kubernetes, and there's ones that have simpler ones like the Blazor app. And Aspire is a product that can make your life easier in both cases, but it's definitely more aimed at the microservices, cloud native, more complicated architectures. That's more of the problem that it is trying to solve. All right, so let's get into resiliency first. So you all heard of the term chaos monkey? You know what I mean when I say chaos monkey? I had ChatGPT generate a pretty fantastic image of a chaos monkey. I rather liked this. The alarm clock down in the bottom right that says Chasso is especially interesting. I think I was trying to do chaos. It's getting a little bit better at generating text, but still it's got a way to go. So anyway, Chaos Monkey was introduced, I believe it was Netflix, maybe it was Amazon, that introduced the idea of a Chaos Monkey. It was a service that they would release into their architecture, probably not in production, probably in dev test environments, and it would throw random errors. And the idea was that they wanted their application to be so resilient that it could handle a chaos monkey unleashing chaos, and they would have enough resiliency in their services to be able to handle it. A .NET equivalent of a chaos monkey might look like this. This is a random failure middleware component, and it's basically saying there's a 40% chance that this is just going to throw a random exception. So my question is, how comfortable would you all be putting code like this into your apps today? The answer should be that you would be fairly comfortable with it, because resilience handling has been around in .NET for a long time. Anyone use the Poly framework? Any Poly fans out there? Poly is a wonderful framework which allows you to retry. It was originally publicly maintained, independently maintained. It was open source, and then Microsoft brought it in and incorporated it back in, let's see, I think .NET Core 2.3 or maybe 2, maybe 3, .NET Core 3, something like that. And they brought it in, and one of the packages that they made available was Microsoft extensions.http.poly. So with that, .NET Core 2.1, there we go, 2018. With that, when you set up your factory for an HTTP client, you set up, you can add this additional add transient HTTP error policy. And then you can put in policies like your typical poly policies, like retry async. So this says, I want you to connect to localhost 5130, and anytime anyone ever asks for a product service, and when they do, I want you to automatically retry up to 3 times. And if it fails after the 3rd time, then go ahead and stop. Scott Hanselman has a great article on this. It's a bit dated now, but this is he's got, actually, this is 2018. He's got a number of blog posts on this topic, but definitely worth reading. But things have changed since then, because in .NET 8 they added an update to this. This is the add standard resilience handler. So if you turn on the add standard resilience handler, instead of being really explicit about what your policies are, Microsoft has just said, we're gonna give you what we think are the best policies in general. You customize it, but we're going to start with what we think are the best policies that you should be using. And so those policies that you get out of the box are a rate limiter, a total timeout, a retry, a circuit breaker, and attempt timeout. Now, you probably already would have thought of adding a retry policy. That makes sense. But what they wanted to be able to handle was denial of service attacks. If you're initiating a denial of service attack, even if it's by accident, this is going to limit the number of concurrent requests. And if the endpoint that you're calling is returning errors, maybe now's not the best time to overload them with a whole bunch of requests, because you could be making a bad problem worse. And so there's a circuit breaker, which is trying to block if too many failures or timeouts are detected. It's trying to slow things down a little bit. There's a total timeout, so that 30 seconds is the maximum that a request should take. Again, all these things are customizable, but this is what Microsoft feels like is a great starting point for resiliency across all apps. So why aren't you using these? I don't know. No one actually answered the question of, I actually am curious if anyone's using any of these. I don't know, Sean, are you got resilience handlers going on in your app? The answer is probably, if you're not using them, which is what I suspected a lot of people would say. The answer is probably, well, I knew it was a thing, or maybe I didn't even know it was a thing. Queues. Yes, that's a good answer, actually. It's a very good answer. Yeah, so, but I mean, still useful, especially from a client's perspective, if you have an MVC app or if you have a Blazor WebAssembly app, to be able to make a GET request, or I guess for queues, a POST request, and to have it, if there's a little bit of wobbling in the network, if the network just goes down for a second, it'd be really nice to be able to wait and try it again. So one more thing in this category of resiliency is health checks. So Microsoft has made life back in the microservices world, when these units of work need to be able to say what their health level is. Microsoft in .NET 8 released some APIs which make setting up this a lot easier. So this says, this down here says I can map some default endpoints. I want to make a /health and a /alive. The /health, because we called map health checks, will call into, anytime anyone has said builder.services.add health checks, it's idempotent. So that you can call that as many times as you want. Anyone has called add check, they give it a name and then a callback. Then any map health checks calls will call into the delegate that you pass in to the add check. And so this one, the alive one, is only going to call ones that have the tag live. And so this one right here has the tag live. So if someone hits the endpoint /alive, then it's going to call this delegate here. if someone calls into the endpoint /health, it is also going to call into alive. But if you add a new one and don't give it the live tag, then the alive one will not call it. So for instance, let's say we wanted to have a memory check. We want to just see what the status of the memory is on the server. You could write builder.services.addHealthChecks.addCheck memory OK, and then you can have a little delegate which checks how much memory is available right now, and if the memory usage is high, then you return degraded, otherwise return healthy. And because we did not add the live tag onto it like here, then that only applies to /health, not /alive. So alive is saying, is this alive, and health is giving more general information and including more stuff. So it's a lovely little thing. Would have made my life a lot easier 6 years ago when I was working on the Kubernetes app. And this is another thing which, like, there's no reason not to kind of turn this on, especially in development environments, but it is something that can really help with resiliency. So I've gone on for a while without even talking about .NET Aspire, because .NET Aspire brings together a lot of these best practices into one place and gives you a starting point that, or if you're adding into your existing app, it brings together a lot of things that were already in .NET. With the exception of observability. Observability is something new that Aspire adds. So let's talk about invisible errors. So this is a site here, which I have deployed up to the cloud. And you can see I can hit refresh. Well, it's taken a little while there. It's a lot faster there. Every time I hit refresh, it gives me a different experience. The reason is there's a chaos monkey in here. But you would have no idea that there was a chaos monkey here because of the resilience policies are in effect. This is an Aspire site, which I built and deployed, and resilience is working, yay, but customers aren't going to report that slightly sluggish behavior that you saw in a couple of requests because, well, at the end of the day, it worked, right? So how do you know that there's a bug? And the answer is observability. You need some level of observability. So if you were to, I'm curious how you all would answer something like this today. How would you know that a bug had occurred in your apps? Do you have some kind of a ACM tool, such as Application Insights? Because I use Application Insights, and it's okay. It's acceptable. But if I go to, if I were to go to my Application Insights instance right now, and I were to hop in here, I guess I can go over to the logs, and you can get logs, but they're kind of a pain to get out of here. I find it a little bit hard, and it's got a lot of data, but it's just tricky to use. And so what .NET Aspire brings, which is new and wonderful, is inside of your container apps. Well, this happens to be deployed as a container apps application, but there is a .NET Aspire dashboard. I'm jumping right to the end of, most people give presentations where they start with the code and like, let me add it into your existing app. I'm going to do that. But first, I just want to show you what an Aspire dashboard looks like in production. And the reason why I think it's really cool to see an Aspire dashboard in production is because when you start running into difficulties, it is so nice just to have one place that shows you all of your resources running. So I can see that this app has a thing called a store and a thing called a products, and it has a thing called a cache, which happens to be a Redis, cache. And the store is a Blazor app. It's a Blazor WebAssembly. And then the products is the API that's running in the background. And I can open up any of these and start seeing information about the environment variables, which is really, really handy. And I can see information about the console. Seeing the console logs is actually really harder to do. I found it harder to do than it ought to be in even with application insights. But this is showing me, like, if there was a problem with startup, I could see where the startup issues occurred in the store or in the Redis cache or in the products. In fact, here we go. Here is a failure right now. But this is, oh, this is the random middleware failure. Yeah, this is our chaos monkey. You can see it right there. But this is kind of still hard to read, right? Wouldn't it be nice to be able to see the logs? Well, .NET Aspire dashboard has logs as well. And so I can jump over to the structured logs. And let's say I just wanted to see all warns and errors. These are the warns and the errors. And like, I don't know about you, but I just find this to be a really lovely way to get in and see, oh, computer says no. Yep, there's my middleware error. And I can get my stack trace over there. I guess the stack trace could have new lines in it. It could be a little bit better, but having all this information right here for structured logs and console is absolutely wonderful. But it goes further than that. You can also get information about traces. Traces is where things get fantastic. I find traces to be like an extremely useful solution for in the case of the Kubernetes world, where you've got a call that comes into one pod, which goes to another pod, which goes to another pod, and goes to some service over here, and then maybe goes back and then goes to another service. You can watch the cascade of all the calls throughout your app. So for instance, this one right here, we're seeing that there was a request to the store, which resulted in an error. And this must have been a retry. So yeah, here we go. So it made a request, it failed. There must have been a retry, and then it got over here, and then it ended up returning correctly after the wait and retry policy expired. So that level of insight is fantastic in all apps, and that was why I got excited about Aspire, even for my Blazor server app, because of this view right here. I love this view. But metrics is great too. It allows you to go in. You can take a look at all of your requests, how long the requests are taking. You can see the request duration over here. There's logs. What's lovely about this too is that it's live. So let's take a look at the number of active requests, and I'm going to pop this over here, and then we'll pop the site up over here, and it should be, oh, okay, request duration. There we go. So yeah, so what's beautiful about this is you're seeing these, you're seeing this data in real time as it's actually hitting. Oh, there we go. Yep. Number of connections. So you can see memory usage. You can see, which is really handy if you're starting to run out of memory, which we are in our production app right now. So this has been really useful to be able to debug information about request durations and memory. So there we go. That is a quick overview of the .NET Aspire dashboard. This is something you can add into your apps, and I'll get into how you can do that in a little bit. Now, I'm going to try and find my presentation. I found it. Excellent. Okay, so we talked about invisible errors. Yeah, so I'm gonna get a little bit into how to build this into your app. But before I do, I just want to talk about OpenTelemetry. So OpenTelemetry, and now I've lost my, let's see, does anyone add any comments below? Lost my window where you were at. There you are. Okay. Nope. No more questions. Okay, that's fine. So OpenTelemetry. OpenTelemetry was introduced to solve a problem. And that problem is that back before this standard existed, if you had a microservices architecture and you had a Java microservice and you had a Redis microservice and you had a bunch of different things, you would have to, I mean, depends on who you're trying to send your data to, but every single one of those APM clients probably has their own SDK. So you need to download their SDK into every single one of your microservices. And then each one of those would need to be able to send their data back. But it gets even harder when you start having SDKs, third-party SDKs, because then those third-party SDKs need to be able to support that all of the different APM vendors, and so it just gets it was getting really complicated to be able to get that nice consistent view across entire more complicated architecture. So the industry got together and was like, okay, we need a way that everybody can just read and understand and send the same structured format, and that's in terms of logs, metrics, and traces. It's the three pillars of observability. And so they came up with a standard for sending logs, metrics, and trace information, and had a standard wire protocol for how to send it and receive it. And that is called OpenTelemetry. So Microsoft has adopted this. It's wonderful. And with just a little bit of code, you can get it working in your application. So before I get into that code, maybe it's time to actually add Aspire into a project. So I'm going to give my next demo here. So this is the app that I showed in production earlier. This is the tiny shop. And if I wanted to run this, there's the front end and there's a back end. So, it's a little bit tricky. I have to select one of these as the default project, I guess, and then run it. Or I can right click and do configure startup projects, which is an okay experience. I guess it's good enough. Rider has got a little bit better of experience. Any Rider users out there? But but Visual Studio's multi-startup project experience is fine. So I'm going to start that. I'm going to start that. I'm going to hit OK and hit F5. And now, in this tab, I've got one thing going. I've got two consoles going now. So I've got one console for the front end, one console for the back end. Looks like I got an error over here. And I've got another window that I don't even know where that went to for. Oh, there we go. There's that. So this is the back end that's running. I can refresh that. It's going to get another error. Oh, they all stopped. All right. Well, you get the idea. So that is that's it's a little bit inconvenient for getting things started. So the Aspire team was like, let's have a single way of running all of our apps, and so that's called the app host. Now, most demos, when they're going to show you .NET Aspire, like .NET Aspire is super easy. You just right-click and say Add, and add .NET Aspire Orchestrator support. And that does a lot of magic, but I like to break it down into smaller chunks. So when you add .NET Aspire into an application, it adds two projects. It adds an app host and a service defaults. If you were to do this into your project right now, you might think, oh, I don't know, this might be scary. Like, what all is it going to change? So I just want to show you that it doesn't, it doesn't need to be scary. You can do it in a smaller step than this. If you just wanted to add the app host, you can say add new project. And we can search for Aspire, and I can just add the app host. There we go. I guess there already was one. So yeah, I'm running .NET 8. I thought I might upgrade to 9, which I did on my PC, but I'm on my desktop, which is my work PC. So I haven't upgraded to 9 yet here on this computer because it's like my stable computer, and I just been fiddling around at 9 on the laptop. And Aspire 9's got some awesome new features, but I'm not going to demo those today. All right, so so you can set your app host as your startup project, and what it's done, if I take a look inside of my program.cs, is not much. So I can run this, and let's say I want to take a look at the changes that I've made so far. The changes that I've made so far are really simple. All I've done is added a new CS proj, which is interesting. It has, this is Aspire host. I've added a couple of app setting files. I've added a program.cs that doesn't do much. Launch settings makes sense so far, and I've done the solution file. So this doesn't do much, and when I run it, hey, here's my .NET Aspire. This is that console that I showed earlier, and that's nice, but it doesn't have any resources. So let's go add a couple of resources. To do that, I can say builder dot add resource. It wants a generic, and inside of the generic, it wants me to pass in which of my projects. Well, I guess I have to add a project reference to be able to do that. So I'm going to add one for data entities. Oh, not data entities, one for products and one for store. And now that gives me the ability inside of my generic to say, I want my store to be a resource. And I want my products to be a resource, and I don't know why that's failing. Oh, it wants a string. It wants a name. So I'll get into why this is important later, but for right now. Oh, add project. Sorry. There we go. That's a little better. There we go. I'm going to run this, and now there's going to be a couple of resources, but you're not going to see any open telemetry being sent yet because we haven't modified our app to do it. But I can see our two different projects, and you remember that sort of messy multi-start project behavior? I don't need to worry about that anymore. I just run my Aspire host, the app host, and now I can get over and see my main site, or I can see my API. Hit refresh a couple times until it works. There we go. And we can see all that information. And that's, so that app host is just a little bit magical. It knows how to start up other products. Yes, Ryder. Hey, Greg's there. Hey, Greg. Yeah, so it knows how to start up other products, and so that's just a little bit magical. That's really nice. And we can take a look for here in the console, and we can see the console logs. So that's really nice, but we're not seeing any of the structured logs, the traces, or the metrics. And that's because we have not set up an OpenTelemetry exporter. So we have to be able to add an OpenTelemetry exporter. And that's where the second half of Aspire comes in. The app host knows how to start projects. And as I'm going to get to, it also knows how to download Docker containers, and start download Docker images and run and start Docker containers, which is amazing. I'm going to show that in a little bit, but it knows how to run .NET projects and do a whole bunch of other things. But if here's a question for you, how would you feel about just what I've done so far, adding this to your project right now? If you added this to your project and committed it to your main branch, the thing is, you should feel fine about it, because all we've done is just add new code. This is just the app host. All it does is add code, and it makes references into your existing projects right there. By the way, quick aside, if you're curious, I'm curious if anyone else is curious about where this generic came from. There's a little bit of magic behind that, which I think is kind of interesting. This, remember, this is Aspire host. That is where the magic comes from. If I turn that off, then, and I recompile, these generics, it's not going to know what they are anymore. It's like, what are you talking about? What is store? It's a namespace, but it's used like a type. And the thing that happens when you say is Aspire host here is there's some code generation going on in the background, which happens in your obj directory. You don't need to know about this. This is just like totally behind the scenes. Just if you're curious about how this works behind the scenes, in your obj directory, .NET is generating every time you add a project reference, it's giving you this this class for each project and giving a little bit of information about the project path and some metadata. So I think that's kind of interesting if you're curious how it works behind the scenes. Otherwise, don't worry about that. Doesn't affect you. All right, so you need to be able to export your OpenTelemetry data to turn on those parts of the, to highlight those parts of the Aspire. So I'm going to get back to slides again. The code that you would do that with isn't Aspire specific, just like everything we've looked at in the slides so far. It's part of .NET 7 or .NET 8, but it's not new and it's not really part of Aspire. So you get the resources for free, you get the console for free, but the structured logs, in order to get that, you have to call OpenTelemetry. You have to add a reference to OpenTelemetry exporter, OpenTelemetry protocol, and OpenTelemetry extensions hosting. And then you need to call builder.logging.add OpenTelemetry, and you can provide a little bit of detail about how you want it to do that. And then you need to export it. And so that'll be a builder.services.add OpenTelemetry.use OLTP exporter, and then that turns on your structured logs. Out of curiosity, actually I'm going to jump ahead to any serial log users? If there's any serial log users in the audience, this was just a little bug that I ran into installing this in my Blazor project, and that was that it actually somehow erased part of the dependency injection. And when I was calling get required service on my telemetry configuration object, it erased that. And I think it might have been an order of operations question. I have an open Stack Overflow question that no one's answered yet about why that's happening. But as far as how to fix it, you can just not call get required service. You can just create a new telemetry configuration object yourself with the information. It's not hard to do, but it's a little workaround. Otherwise, adding structured logs is as easy as this. All right. How about getting those traces? Getting those traces is just a little bit more code. You have to call add OpenTelemetry with tracing. And then with tracing, you add a ASP.NET Core instrumentation and HV client instrumentation. And that will get you information for all of the calls that are outgoing, as well as the calls that are incoming. And then metrics is similar. You have to add a couple more packages. In order to get metrics, you have to add instrumentation packages. Instrumentation packages are basically inserting calls, inserting little instructions between every single IL code, all of your intermediary language code. That's basically like, can you hear me now? Can you hear me now? Can you hear me now? And so this does add a little bit of overhead, but it will only get turned on if you turn on the OpenTelemetry exporter. So it's not too performance intensive if you're not actually using OpenTelemetry exporting. So to get that, you call OpenTelemetry with metrics, add ASP.NET Core instrumentation, HTTP client instrumentation, and add runtime instrumentation. All right, so that is observability, and yeah, I don't know. Should I go ahead and finish the demo by adding the service defaults project? I think I will. I just wanted to show you. So I showed you. I'm just going to undo all this, and I'm going to show you. That was how to do it. That was how to do it the manual way. But the other way to add .NET Aspire is to right-click. And this is the way most of the demos do it. They add .NET Aspire orchestrator support, and you need to give it a prefix, which will prefix tinyshop1.service-defaults, tinyshop1.apphost, and it already added for you this code that I did manually. And so now I can add one more project reference. Oh, actually, I did it for the store, and I can do the same thing here. Add .NET Aspire Orchestrator support. It just gave me a warning that said, hey, you've already added .NET Aspire. Do you want to just add it in? And I said, yes, I did. So this might be a little bit more scary because it's doing more stuff, but it's added this service defaults project. And now it's made a reference from the store to the service defaults and from products to service defaults. And in each one of these startup projects, in the builder in the builder here for the store, it is calling add service defaults, and it's calling in down here the use map default endpoints. So those two things are all that's changed. So if you want to take a look at the delta, you can see, yeah, we've added a reference to service defaults. That makes sense. We've added a reference to service defaults from the other project. We are calling in add service defaults. We're calling in map endpoints, doing the same thing for the backend. The backend calls add service defaults, map endpoints. And then otherwise, everything else is pretty much as I showed it to you in the simpler scenario. So then the service defaults here is configuring OpenTelemetry. So that is doing the code that I already showed you. It's doing all of it for you, so you don't need to go back to the slides that I showed you. This is just setting this up. It's setting up the logging, exporting, the metrics exporting, the tracing exporting, and then over here it is if there's an environment variable called OTel export or OLTP endpoint, then it's performing the exporting operation. So this would be safe to run in a production environment, because if you don't have an OTel exporter defined, it just won't do anything. So that's safe. You could do this to your projects right now, and it would be a safe thing to do. Adding default health checks. This is actually doing this code that I showed you before. It's adding the self-check down here. If you don't need this, just comment it out. I mean, one of the really nice things about Aspire is it's taking all these best practices, it's putting all of the best practices into service defaults, but it's giving you back the power to be able to make the changes to it. Don't want health checks? Just go ahead and turn this off. You don't need it. But the nice thing is it's now one place that all of your projects are reaching back into. And so you can make a change in one place and it changes into all your projects. Service discovery I'll get to later. Configuring the HTTP client defaults. I already mentioned about the standard resilience handler. This is adding that standard resilience handler onto all of your HTTP objects throughout your entire application. If you're a little bit nervous about anything that you might be doing, adding into your existing application, I would argue this is probably the one thing to be a little bit nervous about. It's totally worth it. It's a great thing to do, but you do need to think just a little bit about what happens if I make a request to the backend and I'm doing an HTTP post, and that HTTP post has side effects, but then something goes wrong after the side effect. Ideally, everything is in transactions, and the backend, that transaction rolls everything back. But you could potentially, if you have some kind of weird side effects, like on our Blazor project I'm currently working on, it makes SOAP requests sometimes. Imagine you made a SOAP request and then something failed after that, and then that resilience handler kicked in and then made another SOAP request, and whatever, something that you can't roll back from, something that's firing the missiles. This could be a little bit dangerous for. So I would argue just you need to think a little bit about your app. Now, it's not that you don't have a problem already if you don't have transactions in your backend. It's just this could make it a little bit worse. I'm going to get to service discovery later, but that is that's all that the service defaults is doing. We've already looked over pretty much all of the code except for the service discovery so far. And when I run this, when I run the app host, which is already set as my default project, we should see that I've got an existing product with resilience turned on, with observability turned on, and we've got structured logs, traces, and metrics all available. Let's see. Yep, here we go. Boom. There it is. There's the structured logs. I could ask for just all of the errors. I can jump over here, generate some errors. There we go. Yeah, you saw that resilience. That took a little while to run. Guarantee you, same thing we've seen before. I could probably go back here. Six requests. Yeah, it failed, then it failed, and then finally, in the third time, it succeeded and returned a result. But you can see this whole life cycle here in the traces, which is lovely, and the structured logs. Now we can see those errors. So that is adding Aspire to an existing project. All right, I'm going to jump back to the logs, to the Prezi presentation. So the final part of my presentation, I'm going to talk about dev usability. First thing I want to talk about is service discovery. So on that Kubernetes project I was telling you about, this was sort of how things looked inside of the Kubernetes cluster. There were so many ports. So first there's an ingress, then the ingress goes to a service on some port, because every single pod, it could scale those up. You could have one of them, or if you needed to scale up, you'll end up with a whole bunch of them. Well, how do you know which one of those pods you want to connect to? The answer in the Kubernetes world is a service. So services sit in front of pods, and they have various different techniques by which they can find the pod that they want to connect to. So you never connect directly to a pod in Kubernetes, you connect through a service. It picks out a pod for you. And so all the services live on different ports. All the pods live on different ports. If the pods get scaled up, each one of those pods lives on a different port, because everything inside of your cluster is connecting on localhost. And so you end up with, a port for a service, a port for a pod, a port for a service, a port for a pod, a port for a service, a port for a pod. There's so many ports. The networking and all the ports is really complicated. It's really painful, and Aspire would have made my life so much easier because of this feature. And the feature, well, what it looks like from a consumer perspective, first of all, normally is if you have you're adding your HTTP client and your builder.configuration, you're going to retrieve a product endpoint. And so product endpoint's over here, and it's connecting to http://localhost 5228. Is it going to use HTTP or is it going to use HTTPS? Maybe you're using HTTP in dev, and in production you're using HTTPS. So you need to have one for HTTP and one for HTTPS. And each one of those is going to be on a different port. It's not terrible, but wouldn't it be nice if instead of that, I want my HTTP client to just connect to products? I don't care what the port is, just make it easy for me. And this syntax, this HTTPS plus HTTP, is saying, first, I want you to try HTTPS if it's available. If that's not available, I want you to fail over to HTTP, and it'll figure that out for you and do it for you. That's really lovely. And so that would have made that really complicated diagram structure so much easier. I would have had to worry a lot less about ports in that world. And I would just say, hey, my ingress, I just want you to connect to front-end pod. Front-end pod, I just want you to make a request over to webhost pod. Webhost pod, so same thing through the algorithm pod, and just use the names and let the ports figure themselves out, which is especially important because, especially in the Kubernetes world, I didn't want to spin up a whole Kubernetes cluster in my local environment. Most of the time, I was just working in a world where I had this front-end pod, the webhost pod, and a database, and I didn't even care about the algorithm pod and the covariance pod. I would only spin them up as necessary. So I had a different dev environment from I had what was in production, and those ports would all be different. So this allows you to abstract all that information away. And that's really nice. To turn that on, I actually didn't include that in the slides. I should have. To turn that on, it looks like add service discovery. That's really all that's required is you call add service discovery, and I think, is that it? Yeah. You can do it. This one does this. This add service discovery does it for all HTTP clients. You can also turn it on by an HTTP client by HTTP client basis. Now, if you still are deploying your apps the way you do today, not through .NET Aspire, .NET Aspire is adding a couple of environment variables to make that magic work. And if I were to go into, let's see, if I were to go into this Aspire instance and take a look at the stores, the front end, take a look at the details, I'm going to see a, so here we go. This services products HTTP 0, services products HTTP 0, HTTPS 0. These two environment variables are the magic that is making service discovery work. If you open this up, this is giving you the full URL that you connect to. So if you're deploying your apps the way that you always do, then you can simulate that by just setting these environment variables, and your service discovery will continue to work even if you don't have an Aspire app host, which is running your site and setting a bunch of environment variables for you. So that's why I included this slide. If you turn on service discovery, you want that to work, and you want it to work in your existing apps and your existing production environments, just set services, the name that you're using, in this case, products, HTTPS and HTTP ports, and then it'll do that cool failover technique for you. All right, so that's almost the last piece of Aspire that I have to show you. But the second to last piece, so we've got to talk about deployment, which I'm going to do relatively quickly. But integrations is the next really interesting piece of .NET Aspire. So Aspire has two different integrations, and these are, they're really just NuGet packages, but they allow you to do things like adding a Redis container really, really easily. So a service integration is something which, a server integration, which is something which just lives in the app host. So let's do this. I'm going to add an Aspire hosting Redis NuGet package. And so to do that, I go into, by the way, the terminology just changed on these. They used to be called Aspire components, and as of .NET 9, they're now called integrations, Aspire integrations. And there's Aspire server integrations and Aspire client integrations, which I'll get to in a second. I'm just talking about server integrations for right now. So a server integration might look like add a reference, dependencies, add an Aspire. Oh, see, it's even using the old language. It's called Aspire package here. It should be called integration. And I would like to add Redis. And here is an aspire.hosting.redis, which is exactly what I want. I installed 9. I wonder if that's going to work. And what that allows me to do now is if I go back into my app host, I can say builder.add Redis. I can call it cache or something like that. And check this out. I can say with Redis Commander. You guys know Redis Commander? Redis Commander is an additional Docker container that you can download, which allows you to get insight into your Redis environment. So I'm just going to do this, and let's just see what happens. I'm going to bring up my Docker desktop. Oops. Give me a second. While that loads up, load on a different window. Here we go. Here is Docker desktop. You can see that I don't have any containers running, and I don't have any images downloaded. And so when I run this code right here, watch this magic happen. It's showing you that it is there's two new what in Aspire parlance is a resource, which might be, there's different types. So these are the ones that we've only been dealing with thus far are projects, but you can also have containers. And you could give it just a Docker file, and it would compile that Docker file, and then and run and turn that into an image and turn that into a container. And so that's one way of doing it. Or if you just, in this case, Aspire terminology is like, it's a strongly typed solution. They say, what's the exact language? Aspire is a strongly typed solution for adding resiliency into .NET packages or whatever. When they say strongly opinionated, they mean that you're getting IntelliSense right here. I can add Redis, I can add Redis Commander, and I get IntelliSense, and I can provide additional configuration options in there, and that's really nice. And that failed to start for some reason, and so I may just skip over this part of the demo, but that's interesting. But normally what happens is it'll download your images, which it succeeded in doing, and then it'll start your containers, which it failed to do. And I'm really tempted just to stop it and start it one more time to see if this works. Otherwise, I'll skip by this part of the demo because I've got slides for this. Nope. All right, jumping back to the slides. If that had worked, you would have seen it automate Docker, which is really cool. All right, so yeah, you had server integrations with just a package reference. I didn't show it, but you can do like with persistence. And so this is going to say, I want all of my Redis cache keys to expire within 5 minutes. So that's how you can customize that a little bit. Oh, and with reference over here is what enables service discovery. I forgot to mention that earlier, but down here, store is with reference products. That is a necessary component there in the app host to turn on service discovery so that whenever the store uses the string products in an HTTP client, it knows to connect to this, and that's what's setting up those environment variables for you. Similarly, when you say with reference on products to the cache, anytime you use the string cache, it knows via service discovery to connect to your Redis cache, which is wonderful. But thus far, this hasn't really done anything. It hasn't changed our app. All it's done is automated the downloading of some packages in Docker and run those. And as lovely as that is, oh, well, here it is. This is what it would have looked like if the demo had succeeded. You would have seen images. It's automating Docker Desktop, which replaces Docker Compose files. I mean, that is really cool because it's getting your Docker Compose files is a pain, but having it in C# and strongly typed instead of a Docker Compose.yaml file is so much nicer. And then you really easily add add-ons like Redis Commander. Here's a Redis Commander. I was fiddling around with keys, adding in keys, watching the expirations. That worked nicely. And then the second half of integrations is client integrations. You need to actually add Redis, in this case, into your actual app. So this is using output caching. So I added a reference to Redis. I added a reference to Redis output caching, and then there's just calling the regular things you would need to do to enable output caching. So add Redis output cache, use output cache, and then you annotate your HTTP endpoints with enable cache or whatever it is. I can't remember the details. Forgot to put that in the slides. And then here's the magic. This is once you've got your client integrations working, you can see here that the store made a request over to products, and products made a request over to the cache, the Redis cache. It made a retrieval. Turned out that value didn't exist, and so then it did a set. And you can watch the whole cascade of all of the network requests, including the Redis cache. And if I hit refresh and did this again, then I'd be able to see that it didn't need to do a set. It would just do a get, and it would be caching and being super fast. So that is that's where the magic really comes in of the integrations, because if it's added through an Aspire package, then it's already set up with the telemetry. That's part of the promise of Aspire integrations rather than just pure NuGet packages, because doing this by hand previously would have involved getting the Redis package and then getting the OpenTelemetry set up for it. But you don't have to do all of that. It does the service discovery, the OpenTelemetry, and all of that for you, and just makes it so easy. It's lovely. So that's integrations. Last thing I just want to mention is that this is documentation. On that Kubernetes project I work on, I put in so much time and energy into documenting everything because I knew it was complicated. But wouldn't it be nice if you could document all of your code in C#, strongly typed like this, and you're showing what is referencing what else and how everything depends on each other, and what the interval timeouts are. Everything's just in one place, strongly typed, C#. Love it. That is another huge benefit to .NET Aspire. Last piece before I close. I don't know if we had an official time limit, but I was kind of aiming for 1 hour and 15 minutes. So that gives me about 10 minutes. I don't know if if that sounds good. I'm going to hit my goal anyway.
Yeah, I think that should be good. Another 5-10 minutes.
Okay, perfect. Excellent. So deployment, there's the simple deployment option. If you type azd deploy, then it just sends everything up into Azure Container Apps, which is what I did here. This is my Azure Container Apps environments, and it just worked like so easy. Love it. It sounds great, but anyone who's done actual deployments, like, yeah, well, what about X? What about Y? What about Z? Like, what if I want to have a VNet such that this microservice and this Microsoft can talk to each other, but I really don't want them talking over here. Like I really want to do a lot of segmentation so that you have to get from here to here, you have to go through here. If you want that level of control, if you really want to be able to have a custom, Aspire just doesn't support VNets, and it's probably not going to anytime soon. So there's the more control-oriented option of doing a deployment, and the customizable deployment options you can do if you do AZD. Again, sorry, I don't think I mentioned it, but AZD is the Azure Developer CLI, which is different from AZ. If you've done a lot of Azure work, you probably used AZ commands. AZD is a different command downloaded, and it helps you do things like this. You can do AZD infra synth, and that is going to generate out all of your bicep files. So you've got a bicep file here or at least this is a resources.bicep, and you're saying this is where my container registry lives. And when I set up a container registry, you want to customize that. You want to change the SKU level, perhaps. That's things that you can do by changing this bicep file, and you can sync this up into Azure yourself with your own PowerShell scripts. So you've got two options: the simple deployment, AZD deploy, which is probably great for getting started, or if you want the more customizable option, AZD infra synth, and that gives you all of the files that you can use to deploy it yourself. All right, well, that was a whirlwind. I hope that was helpful. So this has been Increased Observability, Resiliency, and Dev Usability with .NET Aspire, and my name is Lee Richardson. If you're interested in these slides, they are available at this link. Got a little QR code over there. If you want to connect, I'm on LinkedIn. I'm on Twitter. I just created a Blue Sky account. I'm also El Pritchard on Blue Sky, but I'm most active probably on LinkedIn. I've got a YouTube channel. I've got a number of popular videos there. If you're interested, there's one on Cake, which is C# Make. It allows you to write a bunch of build scripts in C#, and I've got one on ABP. Those are my two most popular ones. So yeah, thanks for having me. Appreciate it. And if you got any questions, just go ahead and post them in the chat.
Let's take a quick look if there is any questions there. I don't see any. Thanks everyone for joining us. Thank you, Lee. I appreciate your time and walking through the entire Aspire.
Yeah, you bet. Thanks. Have a great evening, everybody.
Yeah,
talk to you later.